presentation. It's Aleksandr Lut. Is Aleksandr here?
Yep, you can hear me.
Yes, we hear you, and upload your presentation, please.
Okay.
Could you please make full screen?
Yes, of course. Better?
Yeah, that's fine. You can start. You have 20 minutes, 25 minutes, I'm sorry, and 5 minutes for the questions.
Okay. Okay, you can see me. Yep. Okay. Hello, I'm Lut Aleksandr Valerievich. I'm a postgraduate student of the South Ural State University, Department of Applied Mathematics and Programming. It's located in Russia. I am very glad to all those who decided to attend my report. Now let's proceed to my research. The title of my work is Inverse Problem for Sobolev type equation of the second order. Let's start with the problem statement. Let U, F, Y, be Banach space. The following operators and functions are specific. Consider problem 1, 2, 3. Equations 1 is a complete inhomogeneous second order Sobolev type equations where the operator A can be degenerate. Conditions 2 is initial Cauchy conditions. And conditions 3 is an overdetermination condition. It arises due to the fact that in order to find solutions to the inverse problem 1, 2, 3, it is requested in addition to find the function v to restore the functions q. Let's talk a short time about the history of this problem. The first study of non-solvable differential equations with respect to the height derivative was given in a first paper in 1885. You can see. One of the first to solve the Cauchy problem for equations of the form S was Sobolev. After from this type of equations was named. Number 3 and 4 represent the work that are the main ones of my research. Paper 5 contains one of the possible applications of my theory. This is Boussinesq law of equations. I will talk about it more detail a little later. And finally, at number 6, only one a large number of works is present which is devoted to the study of inverse problem. I will give a little additional information necessary to understand my result. All of them are taken from work 5 present in the previous slide. The first is the definition of the polynomially bounded operator polynomial bounds of the pencil B. Then it is necessary to introduce in addition a condition A with then it is necessary to introduce in addition condition A under which the operators P and Q will be projected in the next lemmas. Next, I will give lemma 2. It's splitting lemma about axial actions of the operators A and B. And finally, definitions 2 about the varieties of the point of infinity. And also lemma 3 on conditions on the coefficient Boussinesq-Love equations for the polynomially bounds of the pencil B. The first step of my work was the reduction of task 1 to 3 to two equivalent in aggregate task 4 to 6 and 7 to 8, where 4 to 6 is usually called a regular problem, and 7 to 8 is a singular. The main result of the work is to obtain successful conditions for the existent and uniqueness of the solution to problem 1 to 3 formulated in the form of theorem 1 presented on this slide. Moreover, the solutions of the singular problem is present here. Next, the Boussinesq-Love 9 was considered where the function V describes the longitudinal vibrations of a thin and elastic rod at the point X and the time T. The parameters equations was characterized properties material such Young models, Poisson coefficient, material density, and the radius of gyration of the section relative to the center of gravity. The sound function Q is the external load on the rod. Conditions 10 specify the start position and the start speed, respectively. Conditions 11 specify conditions on the rod boundary. And conditions 3 of the original problem will take the form of integral order over determination condition. This problem was investigated by reducing it to the original problem 1 to 3, as shown on this slide. For problem 9 to 12, conditions of unique solvability were obtained present on this slide in the form of a theorem where these brackets and this is the scalar project in Banach space. The next stage of my work was the development of a numerical method algorithm. Due to the loss of time and space, the slide shows only a part of development algorithm. There were 39 steps in total. At the beginning, input data are specified. Are specified. For example, functions, equation coefficients, future at the 19 steps using the method of successful approximation, the desired function Q is found. At the end, the found functions V is displayed and animated graph is built. Based on this algorithm, our program was written in the Maple environment. Here is one of several computational experiments that have been carried out. We set the parameter of the following form. We set the possible error of the desired function Q. The number Galerkin approximation, the light of the rod, various equation function. We get the following formulating the problem 9 to 12. After checking the conditions theorem 2, we obtained the desired function Q already at the first step of successful approximations. Since our resulting error turned out to be less than the specified one, we built this graph. Next, the functions V was found with consist of the sum of solutions of the regular and singular problems, where singular problems is 0. The last step in the program was to display an animated graph of the functions V. The slide shows the function in different period times in the range from 0 to 1. During the research, 3 articles were published in English language and one certificate or registration of the program was received. All results have been repeatedly reported at various conferences and seminars. In addition, all result was carried out with the support of the grant from Russian Foundation for Basic Research. The grant number is indicated on the slide. That's all. Thank you for attention. I'm ready to answer on your question.
Thank you, Aleksandr. Does anybody have questions about this talk? You're welcome to ask questions. Then I have some questions. Can I ask them?
I'm ready.
Okay, could you say what is R mu A of B? I guess on slide 4. Because you didn't say.
Slide 4?
Yes, see, lemma 1, you have 2 operators P and Q, and there is a function R mu A of B in these integrals.
You can repeat, please.
In these integrals P and Q, when you define operators P and Q, there is an operator function R mu A of B. What is this function? And in condition
This,
A as well.
This
yes.
is
yes.
R and this.
Yes.
It's right and left resolvent operator it's it's mu L minus M on A. It's operator.
Mm-hmm. Okay. Thank you.
Okay.
Are there any other questions? Then let's thank our speaker.